In this chapter, we're going to be talking about something called a system of equations. And a system of equations, all it really is a couple equations stuck together into one problem. Or the way I put it on here, multiple equations packaged together. So what you'll generally see is this kind of squiggly brace that we've used before, and then multiple equations. So in this one, we have one equation, two equations right there. Before, we would only deal with one equation at a time, like in our previous chapters. Here, we just have multiple equations. Otherwise, it's really no different than the stuff we've dealt with before. The big focus of this chapter is going to be on solving a system. So finding a solution to a system of equations. And a solution to a system is going to be a point that works in every single equation that's been packaged into the system. So if something is a solution to this system right here, it's got to work in that equation, and it's got to work in that equation as well. So it needs to work in each part. And the last thing I'm going to do in this video is just practice deciding if I give you a point, I want you to be able to tell me, is it a solution, yes or no? Now, as we move on, we're going to learn ways of doing that, like figuring out the solution for ourselves. But if somebody hands you a point, you should be able to decide if it's a solution or not. And all you're going to do, like the first point, I want to know if 4, 3 is a solution to that system, those two equations. I'm just going to plug in a 4 for x and a 3 for y and see and make sure it works in each equation. So I'll do that up here. If I plug that into the top equation, I'm going to have 2 times 4 plus 4 times 3. I want to see if that equals 20. So that's going to be 8 plus 12. That does equal 20. That's good. I'm not done though, because I need to plug it into the other equation and make sure it works there. So when I plug that in, I get 3, because that's my y, equals 1/2 times 4 plus 7. 1/2 times 4 is 2. 2 plus 7 is 9. That doesn't equal 3. So that's bad. Even though this point, 4, 3, worked in my top equation, it didn't work down here. See, you can see right there when we plugged it in. That's not a solution. It needs to work in every single part. So that is a no, not a solution. I'm going to go ahead and erase this work, and let's try out our second points. Again, if I hand you a random point, you should be able to tell me if it's a solution or not. If I plug in this number for x and this number for y, if I do it in the top equation, I get 2 times 1 plus 4 times 10. I want to know if that equals 20. I'm going to get 2 plus 40, that's 42, not even close. And since it didn't work in the top equation, I'm not even going to bother plugging in the bottom one, because it's clearly already not the solution. And let's try out one more point here. We have -2, 6. If you plug in a -2 for x, 2 times -2 plus 4 times 6, want to see if it equals 20. That's -4 plus 24. Okay, that's good. That equaled 20. And if I plug it in the bottom equation, I would have 6 equals 1/2 times -2 plus 7. 1/2 times -2 is going to be a -1. -1 plus 7 is 6. So this third point right here was a solution to the system, because when I plug it in each equation, it worked. So when we're looking at a solution, we just want to know what works everywhere.